Great. So I'm Chuck Lukaszewski. I'm Vice President of Wireless Standards and Strategy at Hewlett-Packard Enterprise, and came into HP through Aruba Networks. We were acquired last year, and I'm part of the CTO office, working on future products and strategy, and also I'm responsible for our standards team.
Awesome. Cool.
So, yeah.
Hi, Chuck. So I think, one of the things that I had mentioned to you when we talked about having you come and talk with us was 802.11ax.
Yep.
We've talked about this at WLPC. We've talked about it at other events. What is that going to mean for us as engineers? What is that, is this an entirely different fundamental change in thought and theory on how wireless networks operate? Are we going to have to basically go back to kindergarten and then start over, or what's the deal with it?
Yeah, great question. So packet captures are going to continue to be more and more complex, I think. The IEEE and the standards community is doing a good job of layering in, with more capability comes more complexity for better or worse. But I think AX really takes us in an important direction, because it's not about maybe getting to a faster PHY rate, right? So you're not going to hear, or we're not going from, you're not going to see the gigabit, gigabit to 10 gigabit type increase. We crossed the gigabit line when we went to 11AC. But what AX is about taking advantage of the airtime that we have and trying to squeeze every little bit of efficiency out of it, because there's a lot of inefficiency in the Wi-Fi layer 2, and some of you, I know, seen my presentations on it at WLPC and so on. So there's a lot of opportunity to actually pack a lot more transmissions in the same amount of time if the standard would allow it. And because today we're limited to 20 megahertz is the minimum channel width, and aggregation regime that assumes that we're moving lots of large frame aggregates around for things like video, when in fact the bulk of the traffic that's on most networks is much smaller traffic. It's web browsing, it's printing, it's service discovery, and so on. So we don't need to burn 20 megahertz of spectrum and 5 millisecond TX ops to take care of a lot of that stuff. So if we can pack it a lot more efficiently. But the converse is that now I'm talking with, if I'm addressing many more stations in the same amount of time, which is what AX is going to give us. And we can talk about OFDMA and some of the underlying technologies. But if I'm now talking to 30 stations at once, 200 stations at once in a single transmission, then yeah, it gets a lot more challenging from an engineering perspective.
Sure. So didn't we kind of somewhat attempt to have something similar to this with point coordinate function that nobody ever did? Because with AX, aren't we going to have something that resembles that air traffic controller, like you said, where they kind of say, okay, you go ahead and talk, now you go ahead and talk, now you go ahead and talk. I mean, didn't we tried to do that, but everybody shied away from that. So why are we seeing kind of that shift towards now having that traffic controller?
Yeah, great. So for folks in the audience who might not be totally current on what PCF is, work on your CWNP certifications. It's hashtags associated with that, right? So we are in a, historically, Wi-Fi has been a completely democratic technology, right? And there's a channel access mechanism where stations compete, and the only sort of preference that's given is based on the type of traffic, right? Voice, video, data, and what have you. And so if we are going to go to an environment where we're packing a lot more users or transmissions in, somebody has to decide who's going to go with each transmission. And so with 11AX, the AP is basically going to serve that role. And for the first time, we're going to have an air traffic controller that is calling those shots on a kind of frame-by-frame basis. And so that's actually really exciting, but it also adds, as we were saying, a little more complexity. Also adds a lot of opportunity. So from a vendor perspective, it's exciting because when I look at that, I see a lot of ways that we could potentially add a lot more value to the system and maybe differentiate by how we take advantage of some of that functionality.
So getting to that point about that new capability that we're going to have, what is that is it taking advantage of any of existing stuff, specifically stuff like K and V and things like that, or is it a whole new thing that's going to come out, part of the protocol that's going to change that? Because it's doing because we're talking about actually talking to multiple clients at the same time, as opposed to just one at a time.
Yeah. So let me just summarize kind of the big breakthroughs or the big kind of technology pieces that are in AX. Again, for probably most people in the audience may have heard the term but don't know a whole lot about what's in there. So there, from a physical layer perspective, the two big changes that are coming are what's called OFDMA, which is a technology from the cellular network, which is orthogonal. Everybody knows OFDM. OFDMA stands for the M is actually different. Instead of multiplexing, it's multiple access. So I can talk to multiple stations at the same time by dividing up the frequency band. So that's one, and I'll come back and say a little bit more about that. But basically, we're going to take the 20 megahertz channels that we all know, and we're going to subdivide them into 9 smaller channels of about 2 megahertz each of which could be talking to a different station. So that's one technology. The next technology is basically the next generation of what we already had, what we got in AC Wave 2, which is multi-user. And multi-user currently is just downstream only, and multi-user with AX is going to be fully bidirectional. So there's a lot of interesting things that makes possible. In particular, I'll be able to multiplex a lot of the things today that are single user in the upstream, right, that don't really need to be single user. So for example, in a multi-user transmission, if I'm sending to 4 stations at the same time, each of those stations has to act, right? So I have to pull each of those stations in turn, so I burn up a lot of time. But now if I have MU in both directions, I can actually multiplex all those acts in one chunk of time, so it's a lot faster. So those are the two kind of big hits. So when I talk about talking to more stations at the same time, it's those two technologies working together.
What do you think about backwards compatibility at all costs going forward? Do we ever get to the point where it's just not worth trying to stick with the old 1 and 2 rates?
On 2.4?
Yeah.
Yeah. So another good question. So AX is actually going to ban 1 and 2 meg rates. The minimum allowable rate in 2.4 is at least in the current draft of the standard, it'll be 5.5. So B rates are still with us. There is a well, and B is getting sort of a new lease on life in the sense that there's an extended range version or operating mode in AX that's kind of aimed at kind of the outdoor, kind of longer range, lower power type scenario. But yeah, so that's very much with us, and AX will run in both bands. As far as backward compatibility for legacy interoperability, that's a requirement of the standard. So it will work. We're not going to step on legacy stations. They will be able to understand the AX preambles in the same way that we've been able.
Yeah, I guess part of what I'm asking is, should there ever be a point where we try to collectively, I know it's easier said than done, but try to collectively pull the plug and make the client side of the world say, okay, enough's enough, let's all move on for the greater good? Or
yeah, so at some point I think we're going to have to cross that bridge for sure. And I think if AX delivers on its promise, then you say, okay, what's after AX, right? What does one do next? If we've squeezed all the blood out of the turnip, so to speak, from an efficiency perspective, then we do start to have to look at EDCA and some of the channel access mechanisms and legacy preambles and so on, and we might have to go there. And I think there's a lot of room for, I mean, my personal view is I think there's a huge amount of room for improvement there, and we have an ability as architects, right? The IEEE is in a challenging position because they have to build one standard that works for all deployments, right, everywhere in the world and all the derivative technologies. we have more flexibility, right? We're closer to the customer or to the deployment case and so on. So I'd like to think that there's some way that maybe a different op mode or something in the standard. And obviously we had that with N and Greenfield, and that didn't go anywhere. And I'm not sure how much of that was because the market wasn't ready for it, or we weren't maybe ready for it as engineers. But down the line, that's probably something we'll have to look at. But this, we're talking, well after 2020 for this kind of thing.
Let me hog it with one more on that, kind of an extension of all of that. What's your opinion? I'll just say I constantly complain about the state of the client market, things that come without, enterprise security support, things that come needing old data rates, things that come with, what seems to me in the support role is just crappy drivers. What's your perspective from somebody who's involved with, higher developments and all this stuff? How do you see the market? I mean, it is what it is, but what's your overall opinion on it?
You mean in terms of sort of client?
It feels like it's very
Maturity?
fragmented. It feels like, there's no cohesive undercurrent for developing clients in general. Like, you got the consumer space, and then you've got the enterprise space, but the consumer space, everything that's in the consumer space gets brought to the enterprise in a lot of spaces. So there really is no line when you think about it.
If only there was an organization, like an alliance of some kind, that could support those things.
There's an elephant over there, just don't look at him.
So I mean, we're going to continue to see consumer technology proliferate into all kinds of enterprise use cases, right? And now we have this sort of hybrid stuff, right? So if you look at the iPad Pro and the Surface Pro and some of these, I mean, we have this sort of, in-between category of a consumer-based device design that's, in terms of form factor or whatever, has some additional features to it to appeal to an enterprise audience. But fundamentally, it's the consumer version of the technology. So I think clearly the vast majority of data devices in the enterprise are going to be consumer driven. There'll be some laptop or sort of business type devices. A lot of excitement on the IoT space about sort of unconventional devices that might come into those environments, but it's very early to know what those will be. Those almost certainly will be purpose-built. Many of those will not be Wi-Fi, by the way, right? How many of you are running Nests and stuff at home? I imagine pretty much most of this crowd, and I'm doing the same thing at home and playing with it. It's great if you've got continuous power, right? And I've got good Wi-Fi connectivity in the home and so on. But if you think about the power budgets of a lot of these devices that need to be connected, they simply, their Wi-Fi is too costly, both at an energy level and actually a cost point. Yeah, Andrew.
On the topic of battery life, have you done any testing around battery life differences between 2.4 and 5 gigahertz on clients? So if they're connected on one radio or one band or the other?
Great question. No.
No. There's no difference, or you haven't done any testing?
No, we haven't looked into that.
Okay.
I'm sure the phone vendors have lots of reams of data on them. So Lee, I'm not sure if I'm fully answering your question.
I guess if I were to ask it another way, I'd say, do you think that the client device makers kind of owe the industry more than they're giving us for continuity of feature sets? I guess that's a better way of asking it. Should Roku support and printers support, 1X, for example, or should everybody drop their old crappy legacy data rates, or should somebody do something better than it is, whatever that is?
Or coordinate on, good roaming decision-making algorithms.
Yep.
And
So there's a couple of different axes you're touching on, right? Supplicant or encryption, authentication capability, right? Radio capability, roaming intelligence, and so on. I think each of these vendors is primarily driven by some criteria that's important for their business, right? So with the phone vendors, it's power, right? It's battery life, and every single decision they make from revolves around that. And so we see consequences like that. So the iPhones, in particular, are incredibly efficient about probing now, right? They don't probe at all unless they start to get to towards that kind of neg 70 edge, which has consequences for other services that we want to deliver, right? If we're doing location services or something along that line. So no, the net is I think they're going to continue to make their own decisions. As always, as a vendor, we're going to have to adapt, and a big part of the value that I think we bring to customers that we probably don't do a good job at talking about is a huge amount of interoperability testing on the one hand to adapt our infrastructure to drivers that maybe aren't where they should be. And then on the other hand is innovating with new features to try to improve their decision making. So client match being an example of the Aruba technology to try to optimize which AP a client is associated to. That's a reaction to the problem that you're talking about. So I think there's a lot that we can do as an infrastructure vendor within the standard to try to improve that, but it's going to just continue to be.
Well, you say within the standard, but client match isn't within the standard. Neither is band steering. I mean, a lot of these things are accessories, right?
But it's not just. We're using a standard compliant method.
Yeah. Okay.
Right.
But I'm saying it's not written into the standard. If you read the standard, you won't find band
Agreed.
steering anywhere.
Yeah, correct. But the standard is, in some senses, I mean, it's there's a lot of building blocks, right? And we can use that in a way that is compatible, as long as we're not doing things that we're not changing the standard, right, or modifying behavior in a way that the device isn't expecting. Right.
So, speaking about standards, Chris Little actually asked a question. He wanted to know concerning the traffic control functionality that's gonna happen in AX. Is there and I know we know the standard isn't fully baked yet. Is there anything in AX that allows for tuning to optimize for different environments, or is it pretty much just set and forget? That's the way AX works. You can't optimize it or change it for your environment.
So I think there are going to be all kinds of tuning and optimizations. All the vendors, when this is available, are going to have to revise their radio management algorithms. We had quite an entertaining conversation about this in Phoenix recently. And that when I was saying that there's innovation opportunities around AX, that's specifically what I'm talking about. So how we decide which stations we're gonna talk to at the same time. Those are things that we, ideally we're doing better than anybody else, and that puts us in a place where we need to be thinking of how we can use the building blocks that are in AX, right?
Are you guys actually doing AX testing right now?
No, there's nothing you can't test. So we did hit a big milestone though. So draft 0.1 was published.
I saw that.
Just a couple weeks back, and so it's gone from just the kind of the requirements phase to actually being standards text. But the time frame on AX is that we're looking at probably 2018 before you're going to see draft 2 products, which is pretty much when the consumer stuff kind of hits the
When
shelves.
Buffalo comes out with a AX draft.
Yeah, exactly. So, so it's kind of on that order. I mean, I think I'm sure the other vendors are in the same category. We're putting a huge amount of work into Wave 2 right now, and maybe that's a segue to multi-user and so on. But we just all started shipping significant new technology in MU-MIMO. And this also poses, another wave of client compatibility challenges, right? The client drivers and how interoperable really is an MU phone from vendor A, with a, MU AP from, vendor B, that type of thing. So we're going to go through that wave all over again, and that's where really most of our attention is right now.
Anything else on 802.11 AX?
AX.
Can you describe a little bit how colorization will work from a practical perspective?
Oh, great question. This is one of my favorite
Yeah.
topics. I do a whole lot of work on spatial reuse, so thanks. So there is one other potentially very interesting technology in AX, and this is one that I think some vendors may take advantage of and some may just not even go there. But it's called BSS coloring, and the idea is to allow some opportunity to have spatial reuse, RF spatial reuse, and we talked about that for years in the high density conversations and so on. The way a color works is that every AP can be assigned a color that's on the same channel, and there'll be basically 64 colors, minus maybe a couple reserved slots. So we might end up with 60 or 62. But basically, if you think about having 20 channels in an environment, normally, and I have more than one AP on the same channel, each of those APs is going to block each other. But now if I can give each of those APs a different color, they potentially, and they're at a reduced enough signal level from one another, there are scenarios where they can both go at the same time and potentially increase the sum, 1 + 1 = 3 from a performance perspective. So
Because of like a near far of I'm close enough to my own cell and they're far enough away that I can effectively block.
Exactly, yeah, and there'll be a new kind of preamble detect threshold where I can ignore stuff from the other AP.
Different color.
Yeah, the other color cell, if it's below that level.
So a coloring scheme is essentially an overlay on top of a channel plan.
Yes. Yeah.
So I have channel 36 here and other channels, but all my 36s, for instance, each one would have a different color, and they could potentially then reuse that spectrum.
Exactly. So 36
more often
blue,
than
36
other
yellow,
ones.
36
Yep.
green, 36 red. But here's where it gets, kind of back to the question from earlier about complexity and so on. So Wi-Fi has never, we've never really had to deal with interference limited operation, except in these sort of crazy corner cases like stadiums, right? Whereas in the cellular network, that entire system, they don't have very many channels, and they're constantly reusing them, and so those networks are designed to operate with a very high level of cell-to-cell interference. We've never had to deal with that because of the way the Wi-Fi carrier sense mechanism works. So with coloring, so if I have 36 blue and 36 red, and they can hear each other at say -75, right? So each one becomes the noise floor for the other if they attempt to go at the same time. So for me to get anything through, I have to be close enough to my AP that I have enough SINR to get the data rate that I want. And so it's going to be it's going to be tricky because unless you can get a high enough SINR to make that make sense, you're actually better off not to use the color and to defer in the classic way. So
Is there going to be any automation to try to provide any insight out of how well I can hear other neighbors on my channel and inform the admin or inform RRM to do the coloring if it's applicable or not?
yeah, so too early to say. So coloring, it just went in the standard. We don't know a lot about it other than that the headers are going to include the color fields, and there's going to be this new threshold. And again, a lot of it just comes back to the vendors. Like we'll have to implement our operating system in such a way to be aware of those levels and almost make, again, this sort of packet by packet or TX-op by TX-op decision about whether we're in the money, so to speak.
So quick question then on that. So based from like a PHY receiver level, right?
Yep.
I start detecting a preamble. If the color's in the PHY header,
Yep.
I've already locked onto that signal. Do I just
Correct.
stop locking onto that signal and then allow myself to free up and not be busy and lock onto another signal?
Exactly. You can go back to idle immediately.
It's a shunt to idle.
Exactly. Yep. Yeah. So you're free to receive or TX all over again.
Do stations participate in coloring?
Yeah. So they inherit the color of their cell basically.
So they'll put the color of the cell that they're in their header, and that way an AP won't have to distinguish between whether it's another BSS or it's a station in the BSS in a different color. He can just ignore either.
Yeah, so that's part of the thing that's not defined yet. So we don't know. So the color will be in. There'll be an IE for it. It'll be announced in in a beacon, obviously. It will be in the MAC, or actually it'll be in the PHY header, you're correct. So how exactly that works and in an actual implementation, we're not that far along yet, but it's gonna have to be something along that.
It's going to have to be in every transmission.
Yeah.
Every time you roam, that client's got to update its PHY
Like it
header.
does with everything else, though. I mean,
Yeah. Well, and again, I think I talked about this in Phoenix, but what happens to the nav, right? So the timer now, if I'm ignoring, if I want to defer properly to stations that are in my BSS, but I don't want my nav to change when I pick up traffic from the other BSS, then I need to have more than one nav, right? And there are rules about when I update the remote one and when I don't, and so on. So that's, and everyone that participates in the cell would have to do that. So the stations and the APs would all have to.
good question off of Twitter. Does coloring only work within the same ESS, or will it work across different vendors, APs, neighboring multi-tenants? Like, how will it work across neighboring wireless LANs? So if I have a neighbor out there and they're
Yeah.
doing coloring, does that affect mine?
Yeah, so it'll be in the header. So it's not a vendor specific thing.
So I can't it's just not for my network. It's still, any network that's out there could potentially still, if it happens to be colored the same.
Yeah, so back to the radio management algorithm. So it's sort of now, in the way that we do radio and power planning, color planning will have to be part of that. And just like we sense neighbors for interference to choose channels and set our power levels, we'll have to do the same thing for color distribution. I wouldn't want to put two blues next to each other.
Sorry, excuse me. So if you have one WLAN with vendor A and one WLAN with vendor B, are they going to hear each other's color coding? I guess it would depend on the implementation of, but will they interpret that and go, okay, this AP who hears this AP on 36 red,
Yep.
or will they talk back and forth, or not talk back and forth, but go, we
Be
can
able to
both be the same
navigate
color,
around one another.
color? Yes.
I expect so. That would be the logical thing. Just like, again, in channel planning, right? I know all my neighboring APs, whether they're mine or somebody else's, and I'm going to choose channels, right, to try to optimize around that. So it's a very similar problem working.
So how do you, because obviously this is going to help with the co-channel issue, but how does, if this is going to be backward compatible, so we're going to have a mix, especially in the beginning, we're going to have a mix of clients, legacy and AX clients. How, I mean, if the AX clients can deal with it because they can differentiate the colors, but the legacy clients can't.
Yeah, so the way that'll work is that the legacy preamble, so just like with AC and N, right, once you there's this legacy preamble that everyone understands, and then as soon as I get past that, all the legacy, like the 11A, 11G clients know is that the channel's busy for a certain amount of time, and then what happens in that bubble is they don't care necessarily. So this will be exactly the same way. They'll just know that the channel's going to be busy for so many microseconds or milliseconds.
What do you think about BSS coloring? I mean, I know this is all speculative long term, but are we going to be having 5 years from now religious debates around whether you manually color your APs or let RN
Go around
do
with
that
a marker,
themselves?
red, green.
What if the AP's LED flashed its color?
Put that in the spec.
Nice.
I mean, my assumption is we're going to rely on some sort of automation to auto pick the color, but
Yeah.
do you see that as another step to Wi-Fi design?
Well, we wouldn't be architects if we weren't debating the right way to do something. So, it's another thing that there's a lot of richness in the standard, a lot of material for us. But I know. I think there could well be debates. The number of permutations goes up, right? Yeah. So, the optimal. Does it go up so high that it's not practical to do? Like you could almost argue, so in a stadium today, if you do, so we have this problem with the channel plans now. Right? If you do a static channel plan on 2.4, which is I think what most vendors do, but you're doing dynamic on 5, right? There's a lot of permutations, right, of those combinations of what a single AP could be. So you add color into that mix. right? So I multiply that times 64. So it starts to get in the realm of it's not practical to do it statically, but I'm sure that won't prevent us from
Trying.
Now,
meeting.
do you see AX kind of rolling out any different from every other standard before it? Like start off pre-standard, maybe SMB type stuff first, and then work its way into the enterprise? Or do you think it'll just not really be suitable for SMB? Or is there just anything so profoundly different about this that we should expect a different evolution?
Yes. So, good question. So there's consumer and enterprise, right? And I don't know how to answer the consumer question right now because I think the belief that was really powering AC in the consumer side was that we're going to see a lot of video, we're going to see a lot of really high bandwidth use cases in the home, and Netflix, and there's enough evidence that that's probably true. I think that's a case where you'd want to see wider channels or larger OFDMA resource unit allocations. In the enterprise, we don't maybe see quite as much video and the high bandwidth stuff coming in. So it's going to be very interesting over the next couple of years to see if we really cross the chasm in terms of some of the IP, the enterprise instant messaging and teleconferencing systems. We're doing a huge amount with Skype for business and similar platforms. And I think as those really proliferate into a lot of the places that don't have them yet, we could well see a lot more demand on the system, but it's just too early to.
Well, this might be an unfair follow-up to that, but it seems like a lot of the, go to Amazon and find the most over-marketed thing, hyped up the top end of the 11AC, standard that'll never be realized, but that's what's being put out there. Do you think the marketing folk are going to potentially bungle AX as bad as they bungle everything else, as far as just the dramatic, ridiculous claims of things that you're never going to really realize? It feels like that's what pushes a lot of the consumer
Absolutely.
stuff.
You have a doubt?
Yeah, it's who has the bigger number. Yeah, I mean, it's hard. It's it's a complex technology, and so how do you, if you're trying to reach somebody who's going down the aisle at Best Buy or Fry's or what have you, how do you get them to stop and pick your box, right? So having a bigger number is one way to do that. In the enterprise space, we have a little bit, it's different dynamics, right? Customers have different kinds of requirements, and we can have a more, in-depth conversation about what's the best fit. Right? AP model is a good example of that, right? Do you buy the premium top of the line model? Is it okay if you do a more entry level model, or do you mix and match, right? So that's a conversation we have with a lot of different customers. Even though in most cases, I mean, today I think there's not that much difference in terms of PHY rate,
Sure.
right, between the low and the high end. Maybe an extra spatial stream,
The other features.
yeah.
It's chipset, memory.
Yeah,
performance.
exactly. So, but a consumer isn't going to necessarily care about those things.
Speaking of MCS rates and data rates, what's your take on just the explosion of the number of data rates to choose from and how that impacts clients?
Wow.
Because obviously selecting the right data rate can be a pretty daunting, complex task. Is there any opportunity, is there any rumblings or anything you've heard in the standards bodies to try to simplify that and give clients less choice and say, well, we're going to make it a little bit simpler for you?
How about 4?
Yeah. So I hope what I think is going to happen with AX is there's a thing called the trigger frame. So we said earlier that the multi-user is going to work in both directions, right? And OFDMA will also work in both directions, be downlink and uplink. The way that the uplink portion of the transmission starts is from this thing called the trigger frame, and the trigger frame will include a specification for which stations get to go, how long they get to go, And I think what's going to end up in there is the AP will stipulate the rate.
Based on its signal quality, it's hearing from clients or something like that.
Yeah, TBD.
Yeah.
Right.
Some
Yeah.
method.
So if that's ultimately what's delivered in the standard, then it will shift a little more towards the AP, and we kind of need that because the client no longer really, if I'm just one of 20 stations that's talking to the AP at the same time, the alignment of my transmission with my neighbor's transmission in space and time and frequency it has to be incredibly tight. So there's not a lot of room for the station. If the station chooses a lower rate or whatever and blows out the time limit, right, then that transmission is not going to make it. So so hopefully that'll make it better, but stay tuned.
So a lot of these improvements really, though, seem to be, we really need the infrastructure to manage a lot of this, because, I mean, that's the only way I can see it going forward. How do you see channel planning happening? Because you're talking about breaking up these channels into, so do you do channel planning the same way we do it now? It's just each AP will slice that particular channel up, or are there like, this AP would be on 10 megahertz and this AP would be on 20, or how does that work?
So again, TBD. I think you're going to see, so if it works as expected, I think we'll see a trend back towards larger channels, because some of the reasons why we recommend going to narrower channels, the high density case and so on, if we do that because the radios can't subdivide, right? So now if the radios can subdivide and we get it right, then there's really no harm to using a bigger channel, especially if I'm now aware of, I can do spatial reuse and so on. So we start to look a lot more like the cellular network in that sense. And like I say, we have to do it right? But in that case, then I think you'll see a trend towards bigger channels. You'll also see a trend towards longer TX ops. So this is the other thing, and this may impact legacy stations as well. If we're consistently hitting 5 or 10 millisecond TX ops because I'm packing everything that I can into this burst, right? Because the expensive part is getting the channel. Once I have the channel, I want to shove as much as I possibly can through. So the AX, AP, and clients will have an incentive to use longer TX ops. That could have an effect on legacy stations if they're sending a lot shorter frames.
Oh, I could
I
totally
think
see that.
something that you just hinted at a minute ago that I really want to go back a step and just rehash or dive into is with the MU in the uplink direction and coupled with OFDMA and the nature of the scheduled transmission now, we're getting away from random access in the uplink direction. That fundamentally changes Wi-Fi, number one. Number two is how are we going to, any notion of how we're going to schedule those transmissions for clients? Is the AP going to be informed of what buffer data clients have, or is it going to be some sort of round robin? Because we're fundamentally shifting from almost, like the bursty nature of a packet switch network to some sort of scheduled transmissions where, we have some sort of given offered load that we know is going to be consistent, and we're going in between as a hybrid now.
Yes.
So what's your thoughts on that?
Yeah, good question. So we are for the audience members who are keeping score. So basically, what we just said is that we're taking a scheduled MAC and PHY and encapsulating it in a distributed MAC and PHY with an EDCA, right? So it's PCF wrapped inside EDCA is kind of my oversimplified way I tell people to think about it. So that's absolutely going to be key, and getting the timings right and getting coordinating the transmissions in each direction are going to be really crucial. And so the timing variance, for example. So in the OFDMA world, if I've got 9 2 megahertz channels, and I've got 9 stations, they're all in use, right? So I have 9 different stations. My center frequency offset tolerance, right, has got to be really good. My start of packet right, or my start of frame tolerance and the time domain has to be on the order of microseconds, if not nanoseconds.
Yeah.
Right. Well, really, it's nanoseconds. So these things all just have to work right. Right. So that is the job of the silicon vendors. I mean, the companies that we buy our radios from, they're going to get all that right, and the IEEE is going to work on that bit for it.
Getting back to a topic we were discussing earlier today with Mike around telemetry and Wi-Fi. Today we don't have really good feedback from clients, and the telemetry from APs is legacy SNMP has some inherent limitations in terms of, and Mike gave a great example of 5-minute roll-ups and taking a look at a piece of data over a second, 2 seconds, and seeing dramatically how much that data changed. Are you seeing anything in the standards bodies around increasing telemetry from Wi-Fi clients so that we can, one of the fundamental things about RRM and that people say is that we take one look at the network, which is from the AP's point of view. Are you seeing anything about pulling a client's point of view a little more accurately? We talked about some of the Apple debugs where they're able to tell you how much time the CCA busy is being tripped so that we can get an idea of when we have those problems. Anything around getting kind of that telemetry back through the protocol?
Yeah, well, so again, some of it's implementation dependent. I actually, thanks for mentioning that, because Andrew also mentioned buffers, and I forgot to mention that for the AP to make some of these scheduling decisions, it has to have a way to know how much traffic is queued at the stations, and so there is going to be a polling.
Queue depth indicator, almost like QBSS.
Yeah, exactly. So that's one aspect of it, and also there will be an opportunity. So the clients will need a way to kind of raise their hand and say, "Hey, I've got stuff to," independent of polling, right? A more active type. So there will be a random access type of component to the OFDMA portion of it. Again, just as we have in the cellular system, right? There's a random access channel.
Is that like an action frame saying, "Hey, I have stuff to send"? Or
yeah, and I'm not actually that familiar with the details of it. Again, it's still very much under development, but there is a provision for that kind of functionality. But from a telemetry standpoint, if you're talking about like signal strength and some of the other kinds of things, those standards are going to continue to be. K and B and all that stuff are basically. Those are being rolled in right now, actually, in the 11MC, the next big maintenance release, right? Those are all going to be, just part of the base standard going forward, so they'll be in AX. I hope that we will continue to see improved compliance, right? Because a lot of 11K functionality is, vendors kind of pick and choose, kind of goes to what Lee was talking about earlier. We could certainly do a lot more. So we have this thing we call the virtual beacon report, right, which is we maintain a list of what we think the client sees, each and every client, right, and we do that based on signal measurements and so on. But we actually really don't know without a report from the client. So that's the virtual beacon report is based on an idea that's in 11K, which is the beacon report, right? But not everybody implements the beacon report, which is why we had to create the virtual beacon report. So we tell customers we're 11K ready, right? We built Client Match and some of the other features, expecting that we were going to have more compliance than we actually see. So I can deliver a little better experience if you do support 11K. If you don't, I'll take my best guess at it, right? But I think that state of affairs is going to continue, indefinitely, because some vendors just, it's not a priority.
Is there any benefit to kind of switch real quick? I guess we're running, I don't know how we're doing on time, but to switch it up a little bit, one of the things that we saw yesterday that I really liked was another vendor, Cisco had their Dart connector. And is there any benefit, I thought that was pretty neat, and basically adding some intelligence to the antenna, understanding which antenna to use, when to use it, why to use it. Is there any huge benefit that AX could take advantage of with some type of smart antenna, if you will, or some type of scheduling on the antenna, not just on the radio, but using different antennas?
Yeah, so lot of schools of thought on that. So this is an area where there could be big debate. So the first thing to sort of understand is that there's beam forming when we draw pictures of beams pointing to particular clients. There's really no such thing as a beam anymore, right? That was back in the SISO and the analog days, right? A beam now is a mathematical solution to a matrix math problem, basically, where I'm attempting to achieve a signal maximum for a particular station and a signal minimum for other stations, right? That's fundamentally what MU is doing. So if you could see space in 3 dimensions, right, in our frequency bands, right, you'd see all these hot spots and cold spots and so on that are, but even those are relative to the perception of each radio that's in the environment, right? A one-stream device is going to have a completely different view than a two-stream device and so on. So when the radio is solving these matrix math equations and beam forming, what it's really doing is trying to pick the hot spots, right, for a particular station and cold spots for others. So that's all happening. That's in the math and the standard. So what happens then when I put any type of antenna, right? If I'm manipulating the beam in front of a station. Well, if it's a static antenna array, just a panel or something along that, and I'm just trying to direct the overall energy of the transmission and create a cell of a specific size, that's pretty easy. The math can handle that. If I go the next step and I do a smart array and I'm dynamically manipulating chains on a frame by frame basis, it's not clear how that ties back to the signal processing that's going on in the baseband, right? So to make that work, you really have to close the loop and have a really tight coupling between what's happening in the array and what's happening in the baseband, right? So that you don't inadvertently, get a different result than you're expecting. So can it be done? I think it absolutely could be done. And some vendors talk about doing that sort of thing. Does it justify the R&D involved and sort of the continuing R&D and the complexity of the system, and how often do you get the desired result, right? If I have 10,000 antenna patterns or whatever, that's not for me to say, but I think the standard does really well, that we're getting really good beamforming results and multi-user results without needing those kinds of arrays. I'm skeptical that there's value in, certainly I wouldn't pay more for one necessarily, right? If something that's, because just the radios themselves are doing so much of the heavy lifting now.
No, they're so intelligent they don't necessarily need that.
Yeah.
It's interesting. I mean, it's fascinating because we always hear one side of it, and it's always about the standard and about the software and about the radio, and
Yeah.
a lot of times antennas are just antennas, and it's I like to see innovation on the antenna side to see if there's something that can be done differently, that could help fix that, or even help aid to making a protocol work smoother, or making a transaction work smoother. So
Yeah.
appreciate the answer.
Well, I think where the radio knowledge is going to come back in, again, as we start to get into spatial reuse and so on. I mean, there's a reason that the cellular operators employ large staffs of radio microwave engineers, right? And they use very expensive frequency planning tools with very expensive ground clutter models, right, and so on to really accurately figure out what the SINR environment is going to be, right? We've never had to do that because of this the way that the carrier sense mechanism works in Wi-Fi. We've basically been protected because there's a 30 dB spread between the energy detect threshold and the carrier sense threshold, right? Which has the effect of clearing the cell for us. And I don't think anybody planned it this way, but
It works.
it's what's made it possible for us to roll out all these systems without having to have armies of real people with bachelor's, master's, PhDs in RF and microwave engineering.
I'm glad you're saying this because I keep requesting land use and land clutter data in some of our Wi-Fi tools.
Yeah. So when we
Sounds
get
like we
this,
might actually need it someday.
yeah, but when we get to spatial reuse, now to really take advantage of that,
You have to know your environment.
yeah, so I'm inclined to let the radios do their part of it, not get fancy on the arrays necessarily, but then have a really good RF design that maximizes reuse.
Fantastic.
Perfect. So, unfortunately, we've
Run out of time.
we've come to the end. As we always do, we never have enough time when we get to talk to you, Chuck. I would like to ask if we can end on one thing. That is, how could others get involved to be ahead of the game on these standards, or to understand these standards more as it goes through this process? Because you pointed out very early on that we're probably not going to see draft 2.0 devices, which we would see in consumer space, until 2018 sometime.
Yep,
That
for AX, yep.
for AX, yeah. Well, while that seems like a long ways off, it's not necessarily a long ways off.
Yep.
How can we become more involved? At what steps can we be involved and have access to some of this information to provide comments, or at least read and understand what's coming on there in greater details?
So you mean in the standards, the IEEE process itself?
Yep.
So you have to, IEEE is an open process, but it's but you have to be a member. So anybody can go, and I mean, you can participate and be in the room. The documents are publicly available and so on. To submit a comment, you have to be a voting member, basically, of the body. So
But to access the document, you also have to be a member, don't you?
nope. It's
So you have-
totally free.
Oh, it is.
Well, sorry. So the final standard itself, in the past, some of those documents have had a price attached to them.
Yeah.
802, to try to push out the standards awareness and so on, IEEE has a great program called Got 802, basically, and you can get free copies of the complete standard for a number. I don't actually know all the ones that are included, but .11 is one of those. I think .15 might be one of them as well. So if you you just Google, IEEE Got 802, and you have to identify yourself or whatever, but then it'll give you a download link and you can pull different standards. So if you're interested, that is one way to go. But I got a much better plan for you. So those documents, if you don't have if for the folks in the audience who probably don't have an IEEE background, it's very dense reading. There's a lot of math. There's a lot of. It's very interesting if you're so inclined and you want to put in the time, it's definitely worth it. But a way better way to get started, again, is the CWNP certifications, and that's where I got my start. 12 years ago, it's really when I started doing Wi-Fi's. You can, if you do a lot of deployments and you work at it and you study, and to study you need good materials, right? So I started with the CWNA. That's a good place to get going, right? And you learn a lot of the basics. But it's good to plow through that and get into the AP, not to mention the others, but the AP in particular really starts to drill you into the structure of the standard and how it works and so on. And I think you're in a much better position to then go into IEEE if you've got that foundation. And when a new standard comes out that's got even more complexity to it, by having that foundation, you'll be better prepared to absorb it.
That's a very interesting take, and considering that if Keith and Sam were still present at the table, Keith
Yeah.
had to leave to catch a flight and Sam's not feeling too well, we would have 7 CWNEs sitting at this table. So
Yeah.
I think we would agree with that statement of starting there is certainly good to help you understand then what you will end up reading in the standards.
Yeah, I could not have been, so most of the people that go to IEEE, right, that represent companies like Aruba and Broadcom and Qualcomm and so on and so forth, they go to, their PhDs, with a background in, electrical engineering, statistics, and so on. We all have a different, we come from a different place, right? So I could not have been effective in going to IEEE without building that whole foundation. You can't just show up and expect to participate.
Hey guys, I'm Chuck. What's up?
Yeah.
No, perfect.
Can I ask you a total screwball side question?
Sure, go for it.
not related to any large football game in particular, but what was the most shocking thing that you found, say, in a large public venue deployment over the last, I don't know, 60 days? Have you seen anything that just made you go, wow, I had no idea to expect?
Within 10 miles of this location.
Was there anything that stood out from that experience that you went, wow, that's just interesting?
Yeah, how many CPE devices are defaulted to 80 megahertz channels?
Really?
We had to go kill. Yeah, so there's every day. Actually, you're scanning basically twice a day going into a game like that.
Some type of
There's constantly stuff popping up as you know, because there's hundreds of vendors setting up in the facility, right? And big and small. So you've got a big broadcaster that's got broadcast booths on the sideline, broadcast booth up on the stands, and so on. And they're setting up. They have a lot of Wi-Fi. And then you've got all kinds of other vendors that are doing, you know, various things, and they've all got stuff. So we got to make sure that everything that goes in complies with the frequency plan. And for those that don't, we have to go track it down and, you know, politely but firmly work with them. And
without the steel fist.
Well, you know, so you know, there is a frequency coordinator at the game, so there is a baseball bat available if necessary. Actually, that's probably the wrong metaphor for that game.
Yeah, right.
But no, I mean, what I find is,
Antenna.
Huh?
There's a guy walking around with a directional antenna.
Yeah, well, we had three people
Probably.
walking around with doing exactly that. But you know, I find, you know, radio professional to radio professional. You know, again, as long as there's a plan, right? As long as we've got spectrum available to send people to, which we did for that very reason, people are reasonable and you can get to a good result. That's what we did. So frequency coordination, frequency planning was a big.
Are the vendors already aware of this beforehand? Like, does something get sent out?
So there's documentation that goes, but how many people actually pay attention to it? I mean, a lot of people just have a traveling kit that they move around with, and they expect to use that. So again, it's just part of this dialogue and back and forth with.
But you saw a bunch of them set to 80 megahertz.
Yeah. We had to, you know, we run 20s as I think everybody knows, and so you gotta dial them back because they're taking out 4 channels,
Yeah.
right, in that case. But
Cool.
Perfect.